How many different, this one says for number 7, how many different 3-digit numerals? 3-digit means how many blanks? 3. And numerals means numbers. What does that mean? The first blank can't be 0. Now it says, can be formed from the digits 1, 5, and 8 if the digits can't be repeated. Can't be repeated means we box them, right? Okay? Then B says, how many different 3-digit numerals can be formed from 1, 3, 5, 7, and 9 if they may be repeated? And C says, how many 4-digit numerals can be formed from 0, 2, 3 if the digit may be repeated? Okay? You're doing A, B, C. Try them out quickly. So the first one says, how many different 3-digit numerals, can't start with a 0, didn't give me an option of a 0 anyways, right? So I would have been okay. The digits can't be repeated. So the only restriction is the first one can't be a 0. We don't have that as an option anyways. So we have 1, 5, or 8 as our options, which is 3 options. But when it says does not repeat, it doesn't matter. If it's a word, we know we can't repeat, correct? Unless there's like a double letter. If it says it can't repeat, the moment we say that, we immediately have to hold something. Box it. If you do that, you will get every question right all the time. Okay? So I'm going to box the 1. So then I would only have 5 and 8 for this one, which is 2. Then I box the 5, let's say. Then I only have 8. So your answer you should have had was 6. B says, how many different 3-digit numerals can be formed from 1, 3, 5, 7, 9 if the digits can be repeated? So if it's a 3-digit numeral, I have to have 3 blanks. I can't have a 0 at the front. Didn't give me an option of 1 anyways. And then I have 1, 3, 5, 7, 9, which is 5 options. Now it says maybe repeated. So do I box one? Do I box and hold one? No, because I can repeat them. So I have 5 for this one. Then I could have 5. Then I could have 5. And make sure you have these dots that are not like faint and I have to get a magnifying glass out to see if they are there. Okay? Or not there at all, because you won't get the marks if you don't put the multiplication matters, right? 5 times 5 times 5 is 125. The next one says, how many 4-digit numerals, 1, 2, 3, 4, 0 can't be here, can be formed from 0, 2, and 3 if the digit can be repeated? And people will call me over often, they'll be like, you only gave me 3 digits, 4 blanks, I can't fill them in. But the key thing here is I can repeat them, right? So it could technically be 2, 2, 2, 2, the number, or 3, 3, 3, 3, right? It just can't be 0, 0, 0, 0, because I can't start with a 0. We agree? So the options I have for the first blank, and I always start off with the restriction first, is 2 and 3. So I have 2 options. I don't have to hold it because I can repeat. Then I have 0, 2, 3 for this one, which is 3, then 3, then 3, because these ones don't have any restrictions, right? So what's 9 times 6? 50. The last one is a tricky one, and I'm just giving it to you just in case you happen to get one on the diploma like this, then you've at least seen it before. I haven't seen one, but you could. So this one says, how many non-zero numerals? So that means the number 0 can't exist. That's what a non-zero numeral means. Are possible if some or all of the numerals 0, 1, 2, and 3, if the digits can't be repeated. Okay? So how many digit options do I have? 0, 1, 2, and 3. So I have 4 options, correct? So this says some or all. So normally it's all of them I can use. But this one says some or all. So I could have it doesn't say like a 1-digit numeral or a 2 or a 3 or 4, does it? Just says I can't repeat and it can't be the number 0. That's what a non-zero numeral means. So I could have a 1-digit number, couldn't I? What options could I have for this blank? 1, 2, or 3. I can't have 0 because it says 0 can't. It's a non-zero numeral. So I can't have a 0 in this blank, correct? So I have 3 options for this blank if it was a 1-digit number. Or, what do I do when I have the word or? Add. Or I could have a 2-digit number, right? What numbers would I have for the first blank of the 2-digit number? 1, 2, 3. which is 3. And then it says can't be repeated, so let's pretend I hold the 3. Then I have 1 and 2, so 2. What do I have to remember? It's not 2. I can bring the 0 back. So it's actually 3 options. And I multiply these. So I add the cases, but I multiply the actual numbers in between. Or I could have a 3-digit number. This can be 1, 2, or 3. So I have 3 options. Say I hold the 3. Then this one could be 0, 1, 2, which is 3 options. And say I hold the 2. And this could be 0, 1, which is 2 options. Or I could have a 4-digit number. This would be 1, 2, 3. 3 options. Say I hold the 3. Then it'd be 0, 1, 2, which is 3 options. Hold the 2. Then 0, 1, which is 2 options. Hold the 1. Then 0, which is 1 option. Or I could have a 5-digit number. Could I have a 5-digit? Do I have enough digits to make a 5-digit? No, because I can't repeat and I only have 4 digits. I max out at a 4-digit number. And I min out at a 1-digit number. So this one I would get 3 plus 9 plus 18 plus 18, which is 36, 45, 48. And we're going to flip over. This one here says, Mr. and Mrs. Wagner want a family picture taken with their 3 children, Jeremy, Jesse, and Crystal, which is funny because this is actually my family, minus my one brother. I don't know why I excluded him. He's the funny one, so I should have there's Jeremy, Jesse, and Jamie. I don't know why. Oh, I wanted a middle. If I included my one brother, Jamie, I wouldn't have had a middle spot because there would have been 6 of us. So I needed an odd number of people to make a middle spot. So I had to exclude someone. I don't know why I excluded Jamie. Probably because he's the youngest older brother. Maybe. I have 3 older brothers. He's the youngest of the 3. My dad is John, and my mom is Colette.
Wow. So all kinds of
Yeah, I was... Nonetheless, I do have a brother named Jamie. He's not on here. He's lovely. I like him too. So, Mr. and Mrs. Wagner want a family picture taken with their children, Jeremy, Jesse. There is a Jamie. We just can't include him because I had to have 5. Okay? Or else I had to make up a new name and make us have 7. Which I didn't want to do.
No more family.
And Crystal. This is hilarious because there has been questions in the past on a diploma where it was like, there are this many kids in the family. It was a released one, so I can talk about it. There's this many kids in a family. Let's say 4 boys and 3 girls. They take a picture of 2 of the boys and 2 of the girls. I'm like, who does that? Who takes randomly, like, okay, you 2 are my favorite boys, and then you 2 are my favorite girls, and I'm going to take a picture of you, and you other 2, you just don't get to be in. No one does that. They take either all the girls, all the boys, or all the children together. But that was the question. If you take 3 of the boys and 2 of the girls, how many ways can we rearrange? I'm like, no one does that. That's like, that doesn't happen. That's a bad question. But it was a question. All right. So we want to line them up in a straight line. How many people are there? There are 5. There's really 6, but we can't have an even number to ask the question. So I made us have 5. So we have 1 blank where I put 1 person. Remember, each blank means 1 number goes there, or 1 shirt goes there, or 1 human goes there, right? That's what the blank means. So I have 1 human, 2, 3, 4, 5. We agree? There are no restrictions. But just like ordering textbooks, when a person stands in that spot, you don't just like pick them all back up and then like say, hey, we can put all 5 here again. Hey, we can put all 5 here. Hey, we can put 5 up here. Right, Simon? Hey, I can put 5 here. Right, Simon? Yeah? Mm-hmm. Totally. Totally. Now you can tell your buddy over there.
I'm just so bored.
Anyways, how many options do I have for the first blank? 5. I have Mr. and Mrs. Wagner, M1, M2. And then I have Jeremy, Jesse, this is just confusing, and Crystal. Correct? Why'd I put J1 again? Not quite sure. J2. Okay, so I listed all my options. Now, can I repeat them? Can I like have Jesse stand here, then Jesse stand here, then Jesse stand here, then Jesse stand here, then Jesse stand here, and a picture of all Jessies?
Yeah.
No. And trust me, one Jesse is enough in this world. He's lovely, but he's a very powerful spirit. If he was in here, you'd all be friends with him, and he'd just talk to everyone, because that's how he rolls. Okay.
Isn't that a nice way to say something mean?
No, he literally be friends everywhere. He's very he's very loud, and he makes friends with like anyone, anywhere.
So did my dad.
You wouldn't even know what was happening. You'd just be friends with him. You'd be like, we're friends now, right? And he'd be like, yeah. He friends you, you don't even know what happened. That's real. Okay, so there's 5, and then I can stand someone. So let's say I leave Crystal here. Crystal's me. And then how many people would I have for this one? 4, and then I stand someone there, then. How could I type this into my calculator if I didn't want to go 5 times 4 times 3 times 2 times 1? Little exclamation point, the factorial. Because remember when I can rocket count down by 1 all the way to 1. So 5, 4, 3, 2, 1. If I could say blast off, I can use the factorial symbol. Right, Amelia? Yeah, totally.
That's an exclamation mark.
Yeah, it's a factorial symbol. Oh my, you were here yesterday. Okay. The parents must be at either end of the line. So what do? I still have how many people? 5. 1, 2, 3, 4, 5. And then I have parents either end. So I have to deal with them first because I have to deal with the restrictions first. So this first blank, what options would I have? Mr. Wagner, Mrs. Wagner, correct? I would have? That's 2. And then you hold 1, and then I would have the other option at this end, correct? And then I hold them there. Then I go to the middle, and I don't have any restrictions on the middle. The kids can be in any order, correct? But I place the parents. So how many options do I have for the second blank? 3. And the third? 2. And then the last one? I just put whoever's still there, right? You know, like there's the last kid who's the shortest in the class. You just plop them on the ends of the picture. So they do in class pictures. Yeah, that's that person.
Then how do you do that one? 3 math problem exclamation and give me an answer?
And then you have times that by 2. So you could go 2 times 3 factorial. But I hope that you just do it in your head. Because that's 6 times 2, which is 12. That's a lot of typing for 12. But your steppy choosers, type it in. So 3 times 2 times 1 is 3 factorial. And then 2 times 1 is 2 factorial. But 2 factorial is just 2, right? So you could write 2 factorial, but that's wasting button question. Okay? So your answer would be 12. Now, I want you to do C and D. Try them out. Baby Crystal must be in the middle. I am the baby of the family. I'm just old now. And then D, the children alternate with adults. So try. Okay, baby Crystal must be in the middle. So what do? I say, hey, Crystal, go to the middle. 1, right? Then how many people do I have left for this blank?
3.
Try again. 4.
4. I was looking at
Then I sit someone. Then I have 3, then. So I could technically represent this by what factorial? 4, because 4 times 3 times 2 times 1 is literally just 4 factorial, which is 24. Or you could go 4 times 3 times 2 times 1. The catch on the factorial is sometimes the answers are written in factorial on the multiple choice, so you need to know what the factorial does. Now the children must alternate with the adults. In order for that to happen, I got a little excessive. In order for that to happen, in order for them to alternate, what must we start with? A child. So we'd have to have like a child, an adult, an adult. That's the only way we could alternate. If we start with an adult, we go adult, child, oh, crud. It wouldn't work, right? So how many children do we have for this blank? 3. Then? And then adults? Then? Now, if we do these in different colors so you can see them, paying attention please, this would be 2 then 1 technically, that would be 3, 2, 1, correct? So how could they write this out? The blue represents what? 3 factorial, and the red represents 2 factorial. So they could write this as 3 factorial, 2 factorial, or 3 factorial times 2, because 2 factorial is just 2, or the answer, which is 12. All are optional. Now watch this one. This is where trickery comes in, when they're even amounts. Okay? I literally kicked my brother out of this question so you could have odd. But now, I had to. Even is what's going to happen next. So I had to give you odd, because odd makes it easier. If I give you even, watch out. So there are 3 boys and 3 girls on a mixed league volleyball team. They want to take a picture of their team for the season where boys and girls alternate. Okay? So, 1, 2, 3, 4, 5, 6 people. Each person stands in a blank, right? We know that. Now, when I had 3 children and 2 adults, I knew I had to start with children in order to make them alternate, correct? But when I have an even amount, watch yourself. When I have an even amount, I can start with what? Boy, or means what? New case.
And.
No, you can't just change it to an and. Oh, plus.
Yeah.
Yes.
That's what I was going for.
Okay, I get you. Okay, so we can start with a boy, or we could start with a girl.
So do you do the 2 lines and then like and then add them?
Yeah, I think I think that's what
you
you.
do another one underneath?
Yes.
Yes.
Yes. So we're going to do 2 cases. So we're going to start with boys on this one. And then we're going to start with girls on this one. Times it by exactly. Yep. Both work. You just need to note that when you have an even amount and you have to alternate, you're going to get 2 cases, right? Or you're going to get 1 case times 2, technically, because you can swap them. So if I have boys first, it's going to be 3 for this one, then 2 for this one, then 1. Or 3 for this one, 2 for this one, then 1. And you have to show the multiplication symbols. Make sure you have the dots, just like with the equal signs and rationals. Or 3, 2, 1, 3, 2, 1. So it'd be 3 factorial, technically, right? Plus 3 factorial, or like Amelia said, instead of adding them, you could just go 3 factorial times 2, which is 6 times 6, which is 36, times 2, which is 72, I think. So now, the fundamental counting principle is just a way to solve things where you take one of each item. Okay? You can repeat items, you cannot repeat items, but you take one of each item and you slot it in the line. So you're making words, you're putting people in order, you're organizing artwork on a wall, you're organizing textbooks in a bookshelf, stuff like that. You're organizing it in a row, you can show it with blanks, and in each blank you have one object, one letter, one number. Okay? Now we're going to talk about permutations and combinations, which permutations you can use factorial notation sometimes, or not. But the key thing with permutation is order matters. So a permutation is an arrangement of objects in a definite order, so order matters, where each object appears only once in the arrangement. So for example, 3 stuffies, a kitten, a puppy, and a bunny. We're going to look at this in a second here. If order matters, so like with the pictures we were just doing, did the order in which you stood the people matter? Do you get different pictures if you stand them in different orders? Yes, you do. If I organize something, you close your eyes and I organize it again, and you can say it changed, then order matters. So then it would be a permutation. So we're going to go and actually take the kitten, the puppy, and the bunny, and we are going to line them up. Right, Riley? Make that thing disappear like magic. Okay, good. So, in the first blank, I could have a kitten. I could prop the kitten up, and then beside the kitten, I could put the puppy, and then beside the puppy, I could put the bunny. Or I could start in position 1 with the kitten. And if I just go puppy and bunny again, is there any difference? No, but what could I do to make a difference? Switch the bunny and the puppy. So I could go bunny and puppy, and then it looks different, doesn't it? What else could I do to get another different looking step? Yeah, so I could start off with the puppy, and then go kitten, and then bunny. So I can start off with the puppy again, and then just switch the kitten and bunny, kitten. And then this one I could start off with the bunny, and then I could go kitten and puppy. Or I could start off with the bunny and go puppy kitten. How many different ways could we arrange these? 6. So that gave us 6, correct? And how could we show it in the fundamental counting principle? The first blank I'm going to leave 1 stuffy, the second blank I'm going to leave a stuffy, and the third blank I'm going to leave a stuffy. I'm organizing 3 stuffies in a row, correct? How many options do I have for the first one? 3. And why do I only have 2 for the next one? Because you left a stuffy in the first blank, correct? So now I have 2 options for this one. Then I leave a stuffy here, then I have 1, right? So I could technically go kitten, puppy, bunny, leave the kitten. Then I would have puppy, bunny, leave the puppy. Then I would only have bunny for this one, right? Showing that you take them away. So here it says in the expression n factorial, the variable n is defined only for values that belong to the set of natural numbers. So you have to go from a number down to 1. I call it rocket counting. If you can rocket count the numbers to 1, you can use factorial. So if I go like 5, 4, 3, 2, 1, blast off, I can use 5 factorial, correct? Let's think about it this way, because sometimes people have to see this. So 5 factorial is the rocket count 5 times 4 times 3 times 2 times 1. Now this, you have to wrap your head around this, paying attention. Rocket count always goes to 1, correct? But what if I give you this? 5 times 4 times 3 times 2. It's the same thing, because if I multiply by 1, bless you, it stays the same number, correct? So technically, if I don't get to 1 blast off, I could still write it as 5 factorial. The only reason why is not because of the definition. The definition is I have to go to 1, correct? The reason why I can write it is because it is actually the same answer. So if you went to 2 and blasted off, you'd still get the same answer as if you went to 1 and blasted off, because multiplying by 1 doesn't change it. Okay. So I want you guys to type these in. Give me the answers.